In this demonstration, we're going to highlight some of the ways that our customers have benefited from using SolidWorks Electrical. They're able to create their schematics in a fraction of the time, often less than half the time as they possibly could before, while reducing errors and improving the accuracy and quality. They're able to reuse data far more easily than they could before, so leveraging their prior hard work is a breeze and doesn't involve digging through archives of old projects. And finally, they're able to produce consistently high quality production packages with all the reports, schematics, panel layouts, and everything they need for their projects. So let's get started by seeing how we can improve the speed and reduce errors with SolidWorks Electrical. We're going to be highlighting our intelligent drawing tools, how easily you can rapidly search for components and symbols to use in your schematics. We're going to show how the system will automatically generate the device tags and wire numbers for you, and it will also assist you in the process through advanced reporting and error checking. In this scenario, we're going to design a package sorting system. Now, initially, we'll just start with a single conveyor to move packages from one point to another, but then later we'll add some sensors, pneumatics, and additional conveyors that will allow us to sort the packages. I'll begin by using SolidWorks Electrical's powerful wire drawing tools to create the three-phase power that's going to drive this motor. And as I use this tool, notice how the wires are intelligently attached to each other, and I can also bend them and invert the phases as needed, all drawing automatically. And my symbol palette has a powerful search function, so I'll just type in MOT here to find the symbol for the motor that I'd like. And as I move the motor around on the schematic, notice how it tries to intelligently attach and orient to the wires. And even if I place the motor on top of some wires, how the system automatically trims the wires for me right at the terminals. You'll also notice that the motor has been given a unique device mark here. At this point, 02M1, indicating that I'm on page 2, my power page, and this is the first motor that I've created on that page. With SolidWorks Electrical, we can set up number wiring and device tagging schemes based on any kind of formula we need to. Okay, we'd like to add some protection for the overall system, so let's add in a fuse disconnector. And just a partial search string in the search field gives us the symbol that we need, and we can add it right to the schematic. And now I'd like to add some protection and some control for the motor, so I'll need a 3-pole circuit breaker and contactor. So I can just search for 3-pole, and I'll get the symbols that are of interest to me. Add my contactor, and we'll add our circuit breaker as well. Now we know that the motor is currently showing up as inside my electrical enclosure. If you look over here at my locations tab, it's over on the side of the screen. Well, actually I want my motor to be outside the cabinet, so we're going to put that on the conveyor by drawing a location box around it, and now you'll notice my motor is now listed as being on my conveyor. So we can sort our objects by function, by location, and it's just another way to be able to report on the information that's in the system. And of course, I'm not going to be drawing 3 separate wires directly to my motor from my contactor. Instead, I'll use a terminal strip inside the cabinet, and I'll connect to the motor with the cable. So let's add our terminal strip. And the schematic looks pretty good right now. Let's go ahead and start adding some components here. So in order to make some decisions about the parts we'll use SolidWorks Electrical's component library. So here I can just assign a manufacturer's part, and I can use these filters over here on the side to pick manufacturers I want to use, or even the number of circuits. So here we have a number of different motors. If I only want to find motors with 4 circuits on them to match up with my symbol, I can narrow down my selection very quickly and very rapidly choose the motor that's of interest for me. Now let's zoom in so you can see how all of the information from that motor has automatically populated the attributes of the symbol, from the mark to the part number and manufacturer, and even down to the individual terminal names that manufacturer uses. Imagine how much more time this would take if we had to individually activate and type in these attributes manually. And also consider how many errors we'd be likely to make entering this data over and over again, whether it's in the attributes or in a related field on a bill of materials. And those would be very difficult errors to spot as well. So let's just continue by adding the rest of the components in the system. Component, we'll assign a manufacturer's part. And here I've narrowed down to SWST as my manufacturer, so I'm only finding just the components I'm looking for. So we can narrow down our libraries based on um, our company's preferred components, or we can narrow down by a manufacturer. And in this case, we're just adding the components data that we need to all these different devices. Okay, so those are all set. And before we go any further, let's take a look at some of the error checking in here. I want to make sure that I'm not making too many mistakes. Like I said, these part attributes and typos in part numbers will be very hard to spot. But there are other types of errors that we can make easily in a system design like this. And let's just take a look at a couple of those. First of all, right off the top, our design rule check is telling us that we did not assign a manufacturer's part to any of my 4 terminals. That's terminal strip X1, terminals 1 through 4. I can also see that none of my wires in my system have marks on them. And maybe the reason I didn't put marks on the wires is because it's a very tedious process traditionally. It involves creating a lot of text boxes, and some of our customers tell us that it takes as much as 10 to 15% of their time just putting the different labels on the wires here. Well, in SOLIDWORKS Electrical, it's a bit quicker because all we have to do is click the number wires button, and they all appear just like we want them to. And the other error that it gave us was that we hadn't assigned a manufacturer's part to these terminals. Now, of course, I could go back just like I did with the others and say, say assign component, but let's instead use the terminal strip editor that's built into SOLIDWORKS Electrical. Here I can select my parts and add my terminals to all 4 devices here. I have a nice graphical layout of my terminal strip, and I can even add a cable at this point. So let's associate some cable cores, and maybe we'll want to find a power cable. And let's just start with a 14 gauge power cable. And this gives us all access to all the cores that we can select and be sure that we're lining them up correctly. Okay, we'll associate all 4 of those. And now we have our cable set up. And actually, let's check one other issue as well. We know that this motor that we're putting on here is running on 240 volts. It's a 4 kilowatt motor, so the current's going to stay just under 17 amps. And maybe we have an inrush factor of 3. We also may know that this cable is about 50 meters long. Now, of course, if we had SOLIDWORKS Electrical 3D, we could leave the length field blank, and when we routed the cable to the motor, it would automatically fill in that value. But this will allow us to create a voltage drop calculation to make sure that we pick the right cable for the job. In fact, let's take a look at that right now. Okay, we're in good shape. So cable number 1, we're actually going to drop about 8 volts, and which is only about just under a 3% drop. So that's good. We'll stick with the less expensive 14 gauge cable rather than going up to the larger 10 gauge cable. Speaking of the terminal strip, as far as giving my folks out in the shop who are going to build this cabinet a good tool to go by, I mean, they could look at the schematic and find these 4 terminals on the schematic and know how to wire the device from there. But what I'd like to do is be able to provide them with an easy to read diagram that shows them how the wiring on this terminal is. So let's jump into our documents. Let's go back into that terminal strip editor, and we'll just say generate the drawing. And you'll notice now I have a very easy to follow diagram that's showing my cables, my part number. I know the type of cable I'm using. I know really everything I need to know about this right here. Okay, so we've completed the motor starter power circuit, and now all I need is a way to open and close the power contacts to turn that motor on and off. So this may look like I'm cheating a little bit right here, but I'm going to drag a power supply that I've already used. We'll actually cover this a little bit later in the demonstration. But I'm just adding in a power supply that I've already used. It already brings in the right types of wires and everything, so I'm ready to work. And we'll jump over to the control page. So we're going to create one conductor of our control wire here. And we'll just pull this wire down a little bit. Okay, so now we have connection points showing and everything's ready to go. Now let's think about how we want this circuit to operate. And to do this, I'll use my command palette, or actually with my symbols palette, I'll use my command palette, where I can grab a push button to start the motor. Maybe I'll bring in another push button to stop the motor. And Finally, we'll need a relay coil. So I already created that component K1. We want to add a symbol for it. We're going to add a symbol from one of the available circuits here. Remember, we used the power circuits on the previous page. So here we want the relay coil, and we'll just attach it right up here. If you notice, it actually brought in a table of cross-references telling me where those power contacts are located. They were located on page 2. If you recall, it's our power page, and row 5 of page 2. And okay, so this system is not going to operate for very long with a momentary push button. If I push it on, as long as my finger is on is how long the motor will stay on. So let's use that second contact, normally open contact, off the relay device here. And we'll just drop it, say, right there in parallel with our switch. And maybe we want our push button to be illuminated. So let's go ahead and add an indicator light to let us know when the motor's running. I'll just drag this wire up here and take a look while I drag this wire around. Notice how the wire breaks automatically at each of the connection points, and I can even just drag across sections as needed to complete the drawing of the circuit. So with minimal drawing, remember I only drew 4 wires to get started here. I just drew a little box, and now I've got this whole network just from dragging and dropping and deleting segments that I don't need. So logically, this looks pretty good. Let's go ahead and fix the wire style here. We want to replace this side, the ground side, with our ground wire style. So we'll say we'll propagate to the equipotential, and we'll use ground. Okay, that looks pretty good. And we'll go ahead and number all these wires. And before we go any further, let's go ahead and assign some components. Again, components, assign, seen this before. Component, assign, and we'll grab our push button here. Oh, and I said I wanted this light to be part of that push button, so let's make these the same device. We're going to assign both of those symbols to S1, and by doing that, it automatically brings in the manufacturer data, gives me a cross-reference, page 3, row 2, and labels the terminals appropriately. So now what we need to do is connect our power circuit with the power supply on the previous page. So we'll do that with some origin destination arrows. And if you watch this, this is another way that SOLIDWORKS Electrical keeps me honest here as I'm designing. When I try to connect a power wire with another power wire, notice how the cursor just jumps right to it, either end of that wire. But if I try dragging it over a different wire type, this ground wire, notice it won't let me do it. Even if I'm way over here on the right side, it's still locking on to only a similar type of wire. And I'll do the same thing with my ground wire and attach that. So it kept me from making one mistake, but if you notice by these big blue dots, I did make another mistake. And if you notice, I have wire 204, and I'm tying that in to wire 301. Ground 1 is being tied to ground 2. And that's a real easy fix. The only problem there is I numbered my wires before I tried to connect these. So I'll just fix that. That's just a simple equipotential conflict. We will say, let's keep wire number 204 here, and let's make this one ground 1. So we just have to choose a correct number, and now we have the ability just to double click and link over from one page to the next. So at this point, we've completed the design of our circuit to start and stop the motor, and we've also created the power circuit. So we're ready to go and drive one conveyor right now at this point, and we have all of our cabling. And just a quick check here of our reports in progress. You'll see that we're building a bill of materials actively. We're building a wire from to list actively with all the information about the wires we're using, and also creating a whole lot of other data fields for items I may have to print out a little later on. So in this section, we've shown how SOLIDWORKS Electrical helps designers rapidly create schematics using efficient wire creation tools and user-defined wire numbering. We've shown the search tools and custom palettes that help us find the symbols and the manufacturer parts that we need very quickly. And we've also shown how error checks and rule checks, single button terminal strip diagrams, and automated reporting remove a lot of the most tedious and time-consuming and error-prone aspects of creating high-quality system documentation. In this next section, we're going to look at how SOLIDWORKS Electrical helps users leverage their past work, and we'll look at some more advanced editing and schematic creation features. So we indicated at the beginning that we'd like to make this into a package sorting system rather than just a package moving system. So what we'd like to do is add 2 more conveyors, and then we'll add some sensors and pneumatics to divert packages to those different conveyors based on the sensor input. So one way I can reuse data very easily in SolidWorks Electrical is the way people have been reusing data for years. It's a simple Control-C and Control-V, copy, paste, and we'll place that right on. And notice how the circuit was copied, but now new components were added. So I now have a second circuit breaker. I have a second contactor, and it's even added 4 additional terminals, numbered 5, 6, 7, and 8, to my terminal strip. I also have a second cable of the same type that I used earlier. So the system has really gone through and intelligently allowed me to copy and paste without making me go back and double check all the attributes to make sure that I've updated everything correctly. Now, it's pretty safe to assume that if I was going to use this motor again, I probably want to use the same terminals, the same cable, the same circuit breaker and contactor. So I'm going to take that whole branch here, and we're going to create what we call a macro with that. And if you recall it from earlier, when I dragged in that power supply that you see at the top of the page here, I came right to this palette and I was able to find this macro. And what it did was not only brought in the symbol of the power supply, but it brought in the attaching wires that will go to my power bus, and it brought in the additional control wires that needed to come off of it. So it just saved me some time of selecting the right wire styles and all the other necessary components. But macros can be a lot more than just one part and a few wires here. What we'll do is we'll grab this whole section, and instead of copying and pasting, I'll just drag it into my library right here. So we're going to call this starter for LS112 motor. And now it's searchable from the find box up here, but I've also classified it here in one of my own custom palettes. So anytime I need this circuit again, I can just drag it and drop it right onto the system and hit finish. And if you notice, now we have a third motor. We now have 12 terminals on our strip, and we have 3 motors in location 2. So now that we've added quite a few new wires, let's go ahead and number those wires. Okay, see, it only takes a second. Okay, so let's try to keep the system as simple as possible. What we'd like to do is be able to control all 3 motors with the same start and stop buttons. So what we want to do is just like we did with the light and the starting switch, we made it all one component. We're going to assign all 3 sets of these contactors here to K1. And when we do that, you'll notice all the symbols are grouped under K1, and the terminal names have disappeared because we've already used up the 6 terminals that are actually on this manufacturer's part. So let's take a look at what's going on here. We'll go back to our relay coil. If you back up, you can see all these extra red contacts. These are circuits that I've used in the diagram, but do not belong on this part. So I could either dig through my catalog and replace this component with one that has all 9 power contacts, or in this case, what I'm going to do is just assign a new component. I'm going to add an auxiliary component to this to fill up those 6 red terminals. It's a 6-pole auxiliary power contactor. It looks like we're in business. Let's use that. And now we're all set. So all the terminals are labeled. If I jump back to my power page, you'll see L1A and L1B. So it's assigned each set appropriately. So now that all 3 conveyors are powered, we'd like to add some sensors and some pneumatic devices to detect and divert the packages as needed. So let's start by adding a symbol for a small 6x6 PLC device. And since all the information comes through in the macro, as well as the connecting wires that I need for this, and we'll finish. And we'll just connect the power, and I'll connect the ground with, why not, we'll use another one of those origin destination arrows. Connect ground to ground. Perfect. And now what we need to do is create a little network of sensors that's going to sense some characteristic. I don't know, maybe it's size, weight, could be anything, color of the boxes as they come down. So let's go back to our symbols palette and just grab a kind of a generic 3-wire symbol for a sensor, and we'll let someone else figure out what the logic is going to be that controls this. But the important thing is that we document the system here. So I'm going to drop in one sensor symbol right here. And let's go back to our wire tool. I'm going to connect the output here to the input. And now let's add 2 wires spaced 1/4 inch apart. And this allows me to create both the power and the ground wires at the same time. And since it's very unlikely I'll be running 3 separate wires out to this sensor, I'm going to use a terminal strip inside the cabinet that will allow me to attach a cable to go out to these motors. So the same, or these sensors. So the same way I created the terminals for the motor, just drag a terminal, say OK, and we'll add another one, say over here, going out. Okay, that looks good. And I'm just going to hide these for a second. Oh, if you see this says terminal strip 1, 2, and 1, that's because actually I made a mistake. Change terminal strip. I accidentally created a 3rd terminal strip. I only want a 2nd terminal strip. So now we have terminals 1, 2, and 3 of X2, as you can see. And terminal X3 is empty, so we'll just go ahead and delete it from our system. Now, just like I did with before, I'm just going to add a cable to this. So let's edit our terminal strip. We're going to add our parts and our cable. So let's add parts here. We'll use our small terminal block. And for the cable, let's add a new control cable. So say control AWG. Got this 3 conductor right here. That's exactly what I need. So what I'd like to do is say the yellow is going to go to the output, that's terminal 3. And then we have black to the ground, or yeah, we're going to put black on ground and red on the power. So we'll just grab those 2 and associate. So ground is black and power is red. Perfect. Okay, so the cable's assigned. And now we can just create a bunch more of these. I have 6 inputs. I might as well use them all, right? So let's just select this, and we'll drag, drag a copy down. And maybe just to clean up this a little bit, the symbols are a little close together. So let's just pick that and drag this forward a little bit. And what the heck, we'll say neatness counts here, so we'll line everything up. And we'll just grab that pair now and just copy that down. And since everything's staggered, everything spaces out correctly. And we've just added, as you can see, 6 new cables, 18 new terminals, and this new strip X2. So let's show that. And in fact, we'll go back and edit X2, and we'll go ahead and create a drawing. And we'll take a look at that drawing. Okay, so something we notice here, we have a lot of wire 204s coming into this device. That's because everywhere we have a power terminal, we're jumping out to get down to the next one. Every 3rd input is coming off the power. Every 3rd input is coming off the ground as well. So what I'll do is I'll just add some bridges in here to make this design a little neater here. So let's edit the terminal strip. And so everywhere I see a 204, 3, 4, 5, 6 of those, correct, create a bridge. And everywhere where I have these grounds, create bridges there. It'll generate the drawing again. And as it's creating the drawing, it did move the spacing in. You see we get a lot more stuff on the first page, but I don't like that we've split a cable here, so I can manually just say add a page break after. So I get 4 cables on one page, 2 cables on the next page. Okay, that should look great now. Look at that. So we've got our bridges showing, connecting all of our powers together, and 4 wires on one page and 2 on the other. And let's go ahead and update this this drawing because now for the motors as well. So here's my terminal strip that connects me to my motors. As you can see, I have 3 of those, and I have the same situation here where I'd prefer to use a bridge to connect the grounds together. So we'll edit the terminal strip, create bridges, generate drawings, close, and OK. Okay, so now these are all bridged together. And let's take a look at something else that's happened here. Everywhere where I had a bridge, it's replaced my wire style to indicate that that's actually a bridge. So instead of being a green dashed line, it's this very thin brown dashed line. So I can set up my own wire styles to define what a bridge is. Remember, this was all green and pink wires, and now it's all little brown wires to represent the fact that these are bridges. And while we're at it, let's just go ahead and number all of our wires to make sure everything's set. And maybe instead of seeing the wire marks on the cable, I'd rather see them here on the actual wires. Great. And moving on now, we need to create the pneumatic device. Now, this is a place where a lot of people would get stuck in a system where, you know, a system like SolidWorks Electrical is very powerful. It has libraries, it has predefined symbols, it makes designing really easy. But what do you do when you're designing and you have to start using a component that you've never used before? Well, we don't have to let it slow us down a bit. In fact, I'm going to create a brand new product, new component right here on the fly, and I'm going to use a black box to do that. And I'll specify this as my hydraulic and pneumatic device. So let's classify it as, well, pneumatic hydraulic, other way around. And since I don't have the component in my library, I'll just add it manually. So let's create a part number for it. I don't know, that looks like a good part number. And we'll pick a manufacturer's name. And maybe I want some additional information about it. Maybe I know that its dimensions are 130 millimeters by 75 by 45. And maybe I just want a quick description. Okay, so I know it's a 4x4 manifold, and so I've just entered some minimal information here. Really, all I need is this manufacturer and part number to have the system show up in my BOM. But the description's handy because that gives me a description of what it is, obviously. And the dimensions here will actually allow the system to automatically size a footprint for me when I do a layout in the cabinet. I don't have to go to the manufacturer site and find an accurate model of their of this device. Okay, so I'm ready to start adding some circuits to this device. So we'll just say add multiple. So there's 8 circuits that we're going to create. In each circuit, I want to have one terminal. And I'll take these bottom 4, and these will be my hydraulic and pneumatic outs. And these top 4 up here will be my digital PLC inputs. Perfect. Okay. And with that done, now I'll just select all these and let's add some marks to it so it'll label these for us automatically. In 1, in 2, in 3, and in 4. And we'll call this one out. Out 1, out 2, out 3, and out 4. Very creative names. But if you notice, we can also specify minimum and maximum, wire gauges and information about the component as well. So that can also aid us in error checking. If I try to put the wrong size hose in this device or the wrong size wire in the digital input, it can give me an error message about that. Okay, but I think our device is all set up. Let's go ahead and add it to our catalog. And now it's in my catalog. I can search for this part number. Anyone on my team can search for this part number. I never have to re-enter that data again. So in about 2 minutes, I guess, I was able to create this part out of thin air and have all the information I need to actually use it in a schematic. So there's my part number. And let's go ahead and add those hydraulic or pneumatic devices. So we'll place one here. Just control drag, make another one here. And then we'll stretch these hoses out. And let's go ahead and use our control wires. Looks like we're at a larger spacing, so we'll use 1/2 inch, and we want 4 of them. And we'll just go to the 4 inputs. Okay, so it's almost there. Let's update our black box symbol, and if you notice, the symbol immediately puts in all those 8 connection points anywhere there's a wire touching the box. And now I just need to assign those numbered items to the actual circuits on this device. So let's take a look here. You can see 1, 2, 3, 4, those are my 4 inputs, 5, 6, 7, 8, those are my 4 outputs. So they're in the right order. I'll just drag drag and drop 1, 2, 3, 4 from my black box up to my PLC inputs. And whoops, and I'll drag 5, 6, 7, 8 to the outputs. And if you notice, there's a little dialog box coming up saying, hey, this is a type miscellaneous, black box symbol. I'm tying it to a hydraulic pneumatic. Are you sure you want to do that? So it's another form of error checking because I didn't preset the type of circuit the black box would get. So now everything's assigned, and when I go away, back to the screen, all the outputs are labeled properly for me. So I guess one last little housekeeping step here to take on this schematic is to put the sensing switches out on the conveyor and the cylinders on the conveyor, because you can see the only 3 items I have on the conveyor right now are my motor. And let's do that. We used a location outline before, so let's do that again. Conveyors, change the component locations. Now they're all down here. And we'll repeat the command and just create another one right here. Change component location. Okay, so in this section, we've explored some of the deeper and yet easy to use functionality inside SolidWorks Electrical. We've seen how we can reuse data with either traditional copy and paste as well as with those powerful macros. We've also seen how a macro can not only save time during drawing the graphics, but also leverage previous part and wiring decisions that we've made in the past, which saves us more time and it further protects us from careless errors. And we've also shown how we can add auxiliary devices, how we manage terminal strips effectively, and we've even seen how black boxes and components allow us to add components and data on the fly without having to worry about creating a special symbol or already having a part in our library before we start with the system. In this final section, we're going to look at how we would prepare the final drawing package with formatted reports and a panel layout drawing and intelligent PDF to represent the entire project. Okay, so first we'll create the cabinet that we'd like for the layout for this design. And so I'll create a layout of my main electrical enclosure, and it's now added to my document list. And what I see on this page is now a list of all the components from location 1. We're all ready to go here, so let's add a cabinet. And maybe I don't know, or maybe I actually have an idea of which cabinet I'd like to use. I know it has a 1055 somewhere in the serial number, and we'll add the door to this, and we'll add the mounting plate. That way we can place to put the switches as well as all the other devices. So let's drop in the door and the mounting plate. And I don't really like the size of this right now. Let's change the scale. So we'll right now this drawing is 1 to 10. We'll change it to 1 to 5. Good to go. Okay, we'll slide this over, move a little bit towards the middle. Good. And go back to effectively our to-do list here. So let's start adding some components here to the system. So first of all, we're going to insert our fuse. So we know the power is coming in from the top of the cabinet. Leave a little room for a rail up here maybe, or a duct. And then we'll need our power supply, and let's go ahead and put our circuit breakers on that top row as well. Okay, so now everything's placed right the way we want it. Let's move the circuit breakers a little bit closer to this, and let's pull the power supply back a little bit. Okay, this way we'll keep our kind of low voltage circuits over here, and we'll keep our high power stuff over on the right hand side of the cabinet. And so for the next row, let's add our little microcontroller, our PLC, and we'll add our contactor as well. So let's insert the contactor. And with this, I don't want to put any spacing between these. It's just a contactor and an auxiliary, so there should be spacing there. Let's put the contactor somewhere here below circuit breakers. And I guess for the bottom row, we'll need to add our terminal strips. Let's see what we still need to add. Okay, switches go on the panel, and then we just have these bottom row items here. So let's insert terminal strip for our low voltage items. That's terminal strip 2. Just place it, line it up right below. And we'll place our pneumatic device. Remember, I didn't have a symbol for this, and what the system did was automatically created this box just to represent the size of that. And we'll insert the final terminal strip. That's about where, we're lining up the height properly on there. This one comes up a little bit higher because it has an extra wire terminal on it. And now we can start laying out and figuring where the wires are going to go. So what I'm probably going to do is start with the wires that come out of my power and feed them back up in here into the circuit breakers and then over here to the power supply. So let's add a couple of ducts to do that. Now I want a duct at the top here. I want one at the, copy and paste that duct. We'll bring it down a little bit and then paste another one. And that's all we need. And then we need one more duct actually. We're going to do a vertical duct. So we'll go from the top down. Just fix that. There we go. Okay, and now we're ready to lay out the rails. So we'll insert some rails. Make this rail go out to about there. Let's copy and paste this rail. We'll update its length in just a little bit. And we'll place this one here. And now we can update some rail lengths. So this one's going to be shorter, and this one, oops, and this one's going to be longer. And this is the same length rail that I want to use down below for the bottom row. So let's line those up. Perfect. There we go. And since I created the rails last, they're obviously on top of everything. Let's just fix that. So we're going to say move below entity. We're going to grab our rails. And as a reference object, we'll use the fuse. It's the first one we created. So everything goes below the fuse. And okay, the panel layout looks pretty good there. Let's move on over to see what remains to be added. Still need to add these two switches. Let's insert those. And we'll put maybe vertical spacing of, say, 3 inches. And we'll just put this guy right here on the front panel. Okay, so the panel layout's all done. And now we're ready to move on and create some final reports for the project. So let's look at our Documents tab, see what we have in our system right now. Maybe I want the electrical enclosure drawing to appear right after the control page. And I've got my terminal strips. And let's add some pages here for the reports. So SOLIDWORKS Electrical has all kinds of automated reporting here. I've got actually even have my wire labels and tags that I'm going to print out, but the only ones I really want drawings of are going to be list of my cables, my drawings reference, bill of materials, list of wires. Actually, let's add one more report to this. Okay, so we're going to add my list of cable cores as well. Okay. So perfect, let's add all that. So we'll generate the drawings now. We want our list of cable cores, list of cables, my drawing list, my bill of materials, and my wires, and that's all. The rest of these are just tags. Again, these are my labels for my printer. And as you can see, the system goes to work creating all the drawings for me. And let's hit close. And this really isn't the exact order I want all these documents to appear in, so what I'll do is just rearrange some of these things. I want my drawing list or my table of contents here to be on that. I want that to be the second page right after my cover page. Maybe I want my cable cores list at the very end. And I could set all these in a schedule initially, but I've just decided to do it here. And now we'll just go into process and renumber all of our documents. We're just going to create all the document numbers. So now everything, all the page numbers changed. And one thing you may remember at the beginning, we were talking about how we numbered components based on the page they were on. Well, the power page was page 2. Now the power page is page 3. So this should not be 2Q1. It should be 3Q1. It should be 03 PS1, for example. So let's update all of our marks. And of course that will update all of my bill of materials information as well. So now all my marks are updated. And let's go over to that control page where we have a lot of wire numbers. This 309 through 10 and so forth. In fact, I forgot to number all these. But let's just renumber all the wires. We're going to recalculate all the numbers. So go back and All the wire numbers that were created before have now been updated. This was 308, now it's 408. Now we have 408A, 409A, etc. We have wire numbers for our hoses, actually. And so everything's all set and ready to go. Now what we need to do is just be sure that all of our drawings are updated. So let's just say draw reports here and update all of our selected drawings. Okay, so everything's updated. My drawings list is updated. If I look in my bill of materials, I'll see yeah, motors were on page 2 or 3, the power page, they're 03M1, um, 0, you know, 03PS1. So everything got numbered properly. And if I look at my wires, they're certainly going to be updated as well. There's that 408, 408A, and so forth that we saw on the previous page. So all my reports have been updated, and at this point, really, we're ready to save this package out for our customers. So now maybe our customers asked us for DWG files or PDF files, Excel documents of all my reports. I can save all that, but let's take a look at the PDF export right here. So here I'm going to save out a PDF file. I'll just continue without updating. And so now we have a PDF of this document. So I have this nice professional looking document that's been assembled now, 15 pages. Did the math on this, it's somewhere in the neighborhood of 1,400 data entries in these different cells here. So imagine trying to keep up with that in Excel or some other tool like that, where if I change a part number or I change a page and I have to change all the part numbers and wire numbers, think about what a pain in the neck that would be and how risky that would be in terms of getting errors. But there's some nice things about this PDF. One, I get thumbnails where I can snap to any page instantaneously. Just look at the page, click on it, and it takes me right there. I also get a component index, so I can jump into either the pages of the documents, or I can go right into the components where maybe I want to find where's that motor controller. It takes me right to it. If I click on it here, where does it take me to that controller? It takes it right to the panel layout. If I click on X2, it takes me right to X2. So all the hyperlinks work in the drawing, including my origin destination arrows and all the different symbols. Relay coil, contactor, and there we are on both the contactor and auxiliary. So it really takes me through. So it's a very easy document to walk through, and anybody can use it because it's a PDF file. So in this final section, we've seen how rapidly we can take a schematic and produce high quality documentation in a package that's complete with panel layouts, comprehensive reporting, and even a shareable PDF file that anyone can view on virtually any device. In this presentation, we've tried to demonstrate some of the ways in which SOLIDWORKS electrical users are able to typically cut time to produce schematics and the related documentation by more than 50%. We've also shown how SOLIDWORKS electrical becomes more productive the more you use it, because of the ease of reusing data. And finally, we've shown some of the error and rule checking tools that help us make sure that our documentation is complete, and that helps us reduce ECOs, part procurement errors as well. So all these benefits work to help designers keep their costs down, to work faster, and focus on their efforts on designing the best systems rather than proofreading spreadsheets. In this demonstration, even though we wound up with a 15-page drawing packet, I really only had to create 3 pages, and that was the power schematic, the control schematic, and the panel layout. The system drew an additional 3 pages for me for the terminal strip documentation. So there's nice wiring diagrams. All I had to do was say draw terminal strip, and it did it. The next step here was to create all the report pages. And if we look at those number of those cells that we would have to go back and examine every time we made a major change, like replacing a component or inserting a page, which forces us to renumber our wires or rename our devices, there's nearly 2,000 fields of information that got filled in those 15 pages. Inside the time of 40 minutes, I was able to create from nothing, from a blank template, this relatively simple system that only had 56 components in it, but contained about 2,000 fields of data that needed to be filled in and managed and always kept up to date. Just wanted to leave you with that. And again, thanks for watching.